Timing independent people, what would be another real good way to reduce your sources of error? There we go. Let's measure position independent and graph it so position's on the vertical axis. Yeah. Wouldn't that give me better results? Reduce my error? Hopefully. All right. The lab notebook, if you've looked up on the board, I would like to finish for Wednesday. A reminder. Pronouns do not belong in the lab notebook. There are only 2 places where I am willing to take a pronoun. The only pronoun you may use is the one I. When you're talking about I learned, I discovered, I found out that in part of your summary. The only other pronoun you may use is in the evaluation I liked, I didn't like the lab, and telling me why. No other pronouns. No we's, you's, they's, us's, them's. No pronouns except I. And be writing in past tense, third person, please. And when you talk about what you did and what you learned, you're blending it together. You don't list me the tools and tell me what you did. Or you don't tell me what you did and list the tools. You weave them together. We used a meter stick and tapes and stopwatches to measure the position of our vehicle at given times. Something along those lines. Questions? All right. Let's do a little bit more vocabulary here. All right. So a vector is a quantity, so it shows both magnitude and direction. Megan, what's magnitude mean? So magnitude's an amount? You guess. That's a good guess. Magnitude is the quantity, the amount, the numerical value of your vector. You need to know this word, folks. We're going to use it all year. So make sure you have it written down somewhere if you don't know it. So it's the amount or numerical quantity. My reference tool. I am the 0 reference point. Nathan is going to be our vector, or actually we're going to draw vectors representing his motion. So your job, sir, is you can only walk towards the door or back this way. So you're going to walk for a while and decide to stop. And once you stop, we're going to have, who wants to draw on the board? Chris. Chris is going to draw a vector showing your motion on the board and label it. And then once he's got it on the board, you're going to move again. Your choice of direction for a different quantity of motion. Go. Okay, here's a meter stick. How far, Allison, did he go? Eyeball it. 9 meters? 6 meters? Hunter, you're kind of close. What do you think? 6 meters? Brad Shingy said, so we'll call it 6. Chris, so pick a direction, draw a vector representing 6 meters, and label it. All right. Choose a direction, choose a different distance. Go. All right. How far this time, Joe?
13.
You went 6 the first time. You went less the second time. Can't call it 13.
I didn't agree with the first measurement.
That is our frame of reference, sir. So, here's a meter stick. Something less than 6.
4.
You think it's 4. What do you think? Mitch? 4? Okay, so we need a vector, Chris, that's about 4 meters. Where should it start? Okay, and so make its length appropriate. Okay, hang on, Nathan. We're not quite done with you. All right, so we got 6 meters and 4 meters. Thank you, Chris. Slide over for a minute. We're not done with you either. Okay, so Nathan started there. He ended here. What is his total displacement? How do I find it? Add them together because they're going the same direction. Okay, Nathan, come back to the start. Different distance this time. Go. All right. What do you say far this time?
Like 15.
15 meters. What do you think, Abdi? You think it's 15 meters? Here's 1 meter. 12? What do you think, Keegan? 12? Okay, 12 meters, Chris. Give us a new vector. You can go on another board, or you can go down below, I don't care. 12 meters. All right, Nathan, you're going to come back this way at yet a different distance. Go ahead. You move? Okay, how far, Brad? 1 meter, Hunter? 1 meter? Okay, where does he start, Chris? And where does he go? All right. Thank you, Nathan. Appreciate your help. Chris is going to label it. See, it wasn't that tough, was it? Thank you, Chris. All right. Again, displacement. Remember, displacement is where the object started to where it ended. He started here. He ended here. What is the displacement this time? 11 meters. Okay. How'd you get it? 12 minus 1. Vectors are directional. So I have 12 meters going that way and 1 meter going that way. When direction changes, opposite directions mean opposite signs. So if I make this a plus 12, this is going to be a minus 1. So I have plus 12 going to the right, plus a minus 1 going to the left. That's what gives me 11 meters. Here I had a plus 6 plus a plus 4, so that's how I ended up with 10 meters. I don't care. If you